So now we are going to see some core components of the vulnerability management program. There are certain things like threat modeling, exploit developments, vulnerability intelligence, automation, and vulnerability management on the cloud. So these are some more core concepts that one has to know as a part of the vulnerability management lifecycle. Now, first is threat modeling. Threat modeling is a systematic process for identifying, evaluating, and mitigating security threats. It involves understanding a system's architecture, pinpointing potential attack vectors, and prioritizing security controls based on likelihood and impact. There are various methodologies to perform threat modeling. One of them is Stride. Stride is developed by Microsoft that focus on 6 different categories. Spoofing, that is impersonating a legitimate user or a system. Tampering, whether the data is modifying or without authorization. Repudiation, denying responsibility for an action. Information disclosure, exposing sensitive information to unauthorized parties. Denial of service, making a system unavailable to legitimate user. Elevation of privilege, gaining unauthorized access to higher level privileges. This is a Stride that was developed by Microsoft with the help of data flow diagrams. Another method is called as PASTA, that is process for attack simulation and threat analysis. So this is a risk-centric 7-stage methodology that focuses on the attacker's perspective. It progresses from defining objectives and the scope to threat analysis, attack modeling, and risk quantification. So these are the 7 steps: objectives, technical scope, decomposition, threat analysis, vulnerability analysis, attack modeling, and analysis of the risk and the impact. PASTA is more useful for complex systems when understanding the attacker's motivation and techniques. And how do we identify the potential threats and vulnerabilities? There are various ways to do that. Brainstorming, that is, we should have something like group sessions to identify the threats. Checklists, where we are using a predefined list of common vulnerabilities. Code reviews, so we are manually inspecting the code. Static and dynamic analysis, the automated tools to analyze code or running systems. Fuzzing, we are providing invalid input to find the weaknesses. These are the different ways to get the ideas regarding the threats and vulnerabilities. Then we have something called as exploit development, one of the important topic to be known as a part of the theory. So exploit development is the process of creating code to take advantage of the vulnerability. The understanding of it is very crucial for vulnerability assessment because we need to validate the vulnerabilities, we need to assess their impact, and we need to develop effective mitigation strategies. What are some common exploit techniques? Buffer overflow, where we are overwriting a memory buffer to execute a code. SQL injection, where we are injecting malicious SQL code into a database query. Cross-site scripting, where we are injecting malicious scripts into a website. Remote code execution, where we are executing a code on the remote system. So these are the different exploit techniques available. Then we have something called as vulnerability intelligence. Vulnerability intelligence is the information about the vulnerabilities, including the severity and exploitability. It is used to prioritize remediation and proactively mitigate the threats. Now, how we get the vulnerability intelligence information? There are various ways. First is threat feeds, where we get automated data from the vendors and the security researchers. There are companies which provides you readily consumable threat feed and information. Then we have security blocks, where expert analysis of emerging threats are provided, which we can consume. Hacker News, DFIR reports are few of the examples. We get social media. So Twitter and LinkedIn are the larger one for cybersecurity news and information. And we have the National Vulnerability Database itself. That is a comprehensive database for known vulnerabilities maintained by the NIST and the part of the US government. So these were the vulnerability management data sources, and we can analyze the same using different kinds of tools we have inside our environment. So we can integrate and analyze. Then comes automation in the vulnerability management. Automation is essential because it is providing a key efficient vulnerability management, and it allows you for faster scanning, prioritization, and remediation. So we should have certain type of tools for doing it where we can automate. So we are going to cover Nessus, Qualys, OpenVAS, and few other tools as a part of our practical sessions, end to end, completely from deploying a lab till reports, analyzing, and patch management also. Now, automation we are talking. So there are some automated tasks that we can use with the help of tools. Then we have something called as patch management, where we can automate the download and installation of the patches with the tools like SCCM or third-party tool. Maybe Manage Engine we are going to cover. Qualys is there, Ivanti Patch Manager, SolarWinds Patch Manager. The Microsoft has its own tool that is called the System Configuration Center Configuration Manager, SCCM. We can also use some of the scripting language like Python to automate reporting, system integration, and remediation task. So that is also possible to integrate with, let's say we want to integrate with a SIEM, maybe IBM QRadar or Splunk or Azure Sentinel. We can do that. We can automate the remediation task, creation of tickets, and few more things as a part of the automation that can be typically done. And we have something called as vulnerability management on the cloud. So here we are managing the vulnerabilities in the cloud, which presents a unique challenge due to its dynamic and distributed nature. Now, what are some challenges? First is dynamic infrastructure. Cloud environments are constantly changing, making the tracking difficult. Now, AWS has evolved a lot. Azure is evolving a lot. GCP, Oracle Cloud, IBM Cloud, lot of them, which are the public clouds available, are evolving, constantly changing, constantly getting updated. So to keep up the pace is a bit difficult. There is something called as shared responsibility model. Like this is a division of security duties between the cloud provider and the cloud customer. So who is responsible for what needs to be validated? There is a bit of lack of visibility where we reduce the insight into assets and configurations, and which can make it more challenging to identify and assess vulnerability across all the resources over the cloud. We may have something called as ephemeral workloads. So many cloud resources, virtual machines, containers, Docker sort of things are short-lived and can be spun up and down rapidly. For a day we are using, for a week we are using. So this may not effectively detect the vulnerabilities because the asset disappear before it is going to be scanned. And there are some complexity of the cloud services. The cloud platform offer a wide range of services, database, everything. Azure has around 200 plus services. So managing vulnerabilities across everything is a bit complex and hard. So effective vulnerability management requires lots of challenges to move from traditional practices to new one. So we need to have something called as continuous discovery, automation, cloud native tools. And this way we are going to protect assets and the data on the cloud. So this was something theory part on the vulnerability management essentials. We have one more theory session to be coming up, and then we are moving to complete practical for the time being. Thank you. Stay tuned.